Welcome to the Discover Mathematics series. In this video, we're going to look at how algebra tiles can be used to model multiplying binomials. Let's consider this question. The quantity of x plus 2 times the quantity x plus 1. We're going to use the grid that we've used previously to show multiplication, and I'm going to build the x plus 1 and x plus 2 on the top. So here's an x plus 2 on the top and x plus 1 on the side, vertical. So I have x times x, and that gives me positive x squared. I have x times 1, and that gives me an x. I have x times 1, and that gives me x. And I have 1 times x, and this gives me x. And 1 times 1 is 1. And 1 times 1 is 1. So my answer is right in here, which is x squared plus 3x plus 2. Because I have this one and those two x's, and I can add them together. Let us consider x plus 3 times x plus 2. Now I have x times x, and it gives me x squared. X times 1 is x. X times 1 is another x. X times 1 is yet another x. And when I have 1 times x, I get x. 1 times x is x. And now here I'm going to consider the units. 1 times 1 is 1. And 1 times 1 is 1. I'll do it again. And here I have 1 times 1, and I get 3 more ones, 3 more units. So my final answer, when I combine my like terms, is I will have x squared plus 5x plus 6. And we see what we're multiplying together, and that we'll be able to, in the middle, combine our like terms. Okay, the next example, I have x plus 1 times x plus 3. It doesn't matter which one you actually put on the horizontal and which ones you put vertical, as long as you have each of the different factors. So I have x times x is x squared. X times 1 is x. 1 times x is x. 1 times x is x. 1 times x is x. And 1 times 1 is 1. 1 times 1 is 1. And 1 times 1 is 1. So I have x squared plus 4x plus 3. And the students might ask, how long do they need to use the algebra tiles, the manipulative, and that's until it makes sense to them, until they can figure it out on their own. Now let's consider when we have, now both of these factors had positive terms. Next we're going to look at what happens when we have negative terms. Okay, this first question is x minus 5 times the quantity x minus 1. So we're going to do first, before we go to build it, is make this x plus negative 5 and x plus negative 1. So we're going to put the x plus negative 5 on the top. And x minus 1 will be vertical. Now if x times x, and that gives us x squared, x times 1 is negative x times 1 is negative x, and we do it a third time, fourth time, and a fifth time. Now when we multiply 1 times x, we get negative 1. And we get negative 1 times negative 1, and that's a positive. Negative 1 times negative 1 is a positive, and it's going to be a positive 5 times. So this gives us, when we have the quantity x plus negative 5 times the quantity x plus negative 1, this gives us x squared plus negative 6x plus negative 5. The next example, before we build it, we're going to go ahead and change the signs. So we have x plus negative 3 and x plus negative 2. So we have x plus negative 3 and x plus negative 2. And here we see we have x times x, and that gives us an x squared. X times 1 is negative 1. A negative x, sorry, and a negative x. And we get 3 negative x's. And we have negative 1 times a positive x gives us a negative x. And negative 1 times x is a negative x. And then we have a negative times a negative gives us a positive, and this is a positive, another positive, and another positive. So we see we have x squared, and we have negative 5x plus 6. Okay, some of you may be familiar with another way of seeing it when to transition from the algebra tiles to what's called the box method. In the box method, you write the x plus, oh, in this case it's negative 3, and here it's x minus 2, and you multiply x times x. This is your, like, where the problem is. X times x is x squared. X times minus 3 is minus 3x. Negative 2 times x is negative 2x. x, and negative 3. Negative 2 times negative 3 is positive 6. And then you can combine those terms and you get x squared plus negative 5x plus 6. So the box method is actually exactly the same as what you have over here, except it's not as visual. And here you have one, the minus 3 is 3 separate tiles, but it works exactly the same way. So what we've noticed is when we had both terms being positive, the middle terms added together, and the last term was positive. But when we're both negative, the middle terms add together, but we have a negative number of the middle terms, and the last term turns out to be positive. Now let's see what happens when we have a positive and a negative. Okay, let's look at this question where we have the quantity x plus 2 times the quantity x minus 1. First of all, I'm going to change this to plus a negative. So now I have the quantity x plus 2. Here's my x. Plus 2 times x minus 1, or plus a negative 1. X plus a negative 1. So I have x times x, and that gives me x squared. X times 1 is x. X times 1 is x. Now watch what happens here. Negative 1 times x is negative 1. Negative 1 times 1 is negative 1. And negative 1 times 1 is a negative 1. So now I see there's my answer, but I have two different colors here. So that allows me to create a zero pair, which is this one, a positive and a negative x. Give me a zero pair, so I'll just move those aside. I'll put them over here so I don't move them completely. But here's going to be my simplified answer, which is x squared plus x plus negative 2. So you can see that when we had, if you look at the video when we're subtracting integers, you see that's when we had zero pairs, and that came about because we had a positive and a negative. Let's look at another example. We have x plus 3 times x minus 2. I'm going to change that to plus a negative 2 so I can actually build it. And I see that I have x times x, and it's x squared. X times 1 is x. X times 1 is x. X times 1 is x. And now when we go this way, we see we have a negative 1 times x, and that's a negative 1. Negative 1 times x is a negative 1, and negative 1 times 1 is a negative. Oops. And the negatives times the negative, times a positive gives me a negative here. And now I see I have two sets of zero pairs. So here's a zero pair of the x's, and here's a zero pair with the x's. And so my final answer, or simplified answer, is x squared plus x plus negative 6. Okay, for the next example, I have x plus -1 times x plus 3. So here I'm going to put my x plus -1 and my x plus 3. And x times x is x squared. X times -1 is -x. And +1 times x is x. +1 times x is x. And a +1 times x is another x. And a positive times a negative is negative. Positive times a negative is a negative. And a positive times a negative is a negative. And again, when I look at this, I see that I have a zero pair. This positive x and a negative x give me a zero pair, and I'm left with x squared plus 2x plus -3. Now let's consider on this one, what if it wasn't x minus 3 times x plus 4? What if it was x minus 3 times x plus 3? I'm going to change this to plus a negative. So now I have x plus a -3 times x plus 3. And let's see what happens. To just see this one. So I have x plus 3 times, oops, it should be x minus 3. So I have x minus 3 times x plus 3. And x times x is x squared. X times -1 is -x. And we'll do that 3 times. I have 3 negative x's. Now positive times x is +1. And 1 times x is +x. And another +x. And I have a positive 1 times a -1 gives me a negative. I'm going to do that again. Again, so all the positives times the negatives gives me a negative. The positive times a negative gives me a negative. And when I do this, I get, some of you might have noticed that I get a little square. Makes a perfect square. It's a square. And not only that, but I also have, when I go to simplify, I see I have a zero pair. And I have another zero pair. And I have another zero pair. So I don't have any x terms left. And what I'm left with, I have no x terms, but I have an x squared, which is a square, And then I have a perfect square made out of my 3 times 3 gives me 9. But because it's a negative 3 times a positive 3, I have a negative 9. So this answer is simply x squared minus 9, because all my x terms created 0 pairs, and so they became 0, and I don't have any left. And then I have 2 perfect squares. And the reason why that happened is because the number over here is the same as the number over here, but the signs are opposite. And that's how we got the middle terms to cancel out. And that completes this video. Thank you. Hope it helps.